In the last lecture, we have seen what a series is. It is basically just a sum of a bunch of numbers. So now the big question is, how can we tell what is the value of this infinite sum? What is the value of this infinite series? It is going to converge or is it going to diverge? In the last lecture, we also talked about some well-known series. So if this thing that we are going to add up follows a specific pattern, then we can tell whether this guy is going to converge or diverge. So in this lecture, the convergence test, we're going to discuss more methods that we can use to tell whether this guy is going to converge or diverge. The methods that we're going to be talking about is going to be called tests. So the first one that we are going to be talking about is called the divergence test. Now the divergence test, if we want to find whether this series converge or diverge, so this guy is a series, we take a step back and we look at the sequence instead. If the sequence of an does not equal to 0, then I can conclude for sure that the sum of an, the series, is going to diverge. Notice how this actually kind of go back one step and talk about the sequence to decide whether the series converge or diverge. So if the limit of a sub n does not equal to 0, then I can conclude that a sub n diverge. However, if it is equal to 0, then this sum may or may not, may converge or diverge. For example, if we take a look at this guy, well, this is something that we have seen already. This is just the sum of a bunch of 1. So I'm looking at just a sum of a bunch of 1s, and the limit of 1 is just going to equal to 1, which is not 0. So whenever the limit does not equal to 0, I can conclude right away that this guy is going to diverge. Note once again that to decide whether this series converge or diverge, I actually have to go back and look up the entries in the series to look at the thing that I'm going to sum as a sequence. So let me kind of change the color to make it kind of stand out. Okay. So if I take a look at the next one, I'd like to find whether the sum of n over 1 to the n when n goes from 1 to infinity converge or diverge. So this guy, if I were to write it out, it's going to be 1 over 2 plus, 2 over 3 plus 3 over 4 and so on. 2 over 3 and 3 over 4 and 4 over 5 and 5 over 6 and so on. To find whether these sum converge or diverge, I'm actually going to take a look at the numbers. I'll take a look at just the sequence. If I look at the limit of n over n plus 1 when n goes to infinity. So once again, I'm looking at this thing as just a sequence of numbers. This thing is going to equal to 1. By the way, we actually have found this in the example 3.4 part B, by the way. So we actually have done this earlier. And because this guy does not equal to 0, so I can conclude right away from the divergence test that this guy, the sum now, is going to diverge. It's going to diverge. Okay, so this is how we use the divergence test. Now, if we take a look at the last two examples, notice how if we look at the limit of the sequence in this sum, so if I take a look at the limit of 1 over n, where n goes to infinity, well, when n gets really large, 1 over n is going to get really small, so this limit is going to be 0. And for the last one, if I take a look at the limit of 1 over 2 to the n, where n goes to infinity, this guy is also going to equal to 0. However, if the limit of the number in my sequence is equal to 0, like in the latter two case here, so in that case, then I can't really conclude anything. The sum may converge or diverge. So from the divergence test, that means this two guy is going to be indecisive. So I can't really tell if this guy is going to converge or diverge using this test. However, what we actually have seen earlier that the sum of 1 over n, this is actually just the harmonic series. So this guy diverges. And 1 over 2 to the n, this is a geometric series, so this guy converges. This guy converges. So that means when the limit of the sequence is equal to 0, the sequence itself may actually diverge as called converge.